Okay, our next lesson is about the fundamental counting principle. Okay. What this does is it's going to help us find how many possible outcomes there are when giving any number of events. Okay. In math words, this one's kind of tricky. Event 1 has m possible outcomes. Event 2 has n possible outcomes. Then the compound event of events 1 and 2 have m times n possible outcomes. The big key thing here you need to figure out, or you need to remember, is that we'll be multiplying. Okay. You'll see how we use this in our examples here, but what we're doing is we're using multiplication to find the total number of outcomes with two or more events. Okay. So look at this question here. How many possible outcomes are there for a coin toss and a number cube roll? So if I were to toss a coin and roll dice, how many total possible outcomes are there between those two events? Right? Am I looking at heads and a 1, maybe tails and a 4, right? How many different possible combination of outcomes are there for those three events? And we can use the fundamental counting principle to help us find that number. Okay, so we know that a coin has 2 possible outcomes, and a number cube has 6 possible outcomes. So when we're looking at rolling or flipping a coin and rolling a number cube, and we know that there are 2 possible outcomes for a coin and 6 possible outcomes for a cube, all we have to do is multiply 2 times 6. And we can find that there are 12 possible outcomes. 12 possible outcomes. It's that quick, multiplying 2 times 6. Right, and we can see that from the tree diagram down here. Right, if I know there's a heads and a tails section, it could be heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. It could be tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. Right, and we could do the long way and find out that there's 12 outcomes, or I can simply multiply our 2 possible outcomes from the coin times the 6 possible outcomes from the number cube. And that's all we're doing. We're finding how many possible outcomes are there between these events. In this case, 12. Find the total number of outcomes when rolling a number cube and selecting a letter from the alphabet. Go ahead and try that one out now. Okay, so let's look at our 2 events here. One is rolling that number cube, okay, and I know the number cube has 6 possible outcomes. We just talked about that one. And I multiply it by selecting from a letter of the alphabet. The number of letters in an alphabet is 26. And so all I need to do is multiply my possible outcomes for a number cube times the possible outcomes from the alphabet, and 26 times 6 is going to give us 156 possible outcomes. And you can see why this comes in handy, because I'm not going to go through there and list 156 different outcomes. Right? I'm not going to be able to go through this and say, okay, 1A, 1B, 1C, and go through the entire alphabet for all the 1s, and then go through all the 2s, and then go through all the 3s, and so on and so forth. That's way too many to list. But I can find that number just by multiplying 6 times 26. How many different genes are available at the genes shop, considering these different attributes? So we can see here we have the waist size, 30, 32, 34, 36, 38. The length, 30, 32, and 34. And the style, slim fit, boot cut, loose fit. Go ahead and try it out. Find out how many different possible types of genes there are given these 3 attributes. Okay, so this one we can do quite easily as well. Our first event is the waist size. How many possible outcomes are there for the waist size? I see 1, 2, 3, 4, 5. How about for the length? 1, 2, 3 possible outcomes for the length. And the style, 1, 2, 3 possible outcomes for the style. Right? And all I need to do is multiply. 5 times 3 times 3 is going to be 45 possible outcomes. Right? So if I was at the store and I knew that there was exactly one of every type of gene possible, the chances that I get the exact one that I want would be a 1 out of 45 chance if I was just reaching into that pile. Right? I was looking for exactly my 34 waist size, 32 length, and boot cut. There's a 1 out of 45 chance that I get that specific type of genes. Okay, here's a fun one. Consider a license plate with the following format. It starts off with one letter from the alphabet. It has 3 numbers between 0 and 9. And it finishes with 3 letters of the alphabet. How many possible license plates are there under these specific rules? Go ahead and see if you can figure that out. Okay. All we have to do is figure out each individual event and find out how many possible outcomes there are for each of those individual events and then multiply those numbers together. So I know for the alphabet, there are 26 possible outcomes for this first letter, right? A through Z. Next, a number 0 through 9. There's actually not 9 possible outcomes there. That'd be 10. In fact, there's 10 possible numbers to put in each of those. It could be 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 3, 2, 7, 5, 6, 7, right? It could be multiple different numbers here, but there are 10 possible numbers in each of these slots. And then for each of these alphabets as well, 26 possible in each of these here. So I know in the first slot, there's 26 possible letters to put in, and then 10 possible numbers, 10 possible numbers, 10 possible numbers, 26 possible letters, 26 and 26 possible letters for that last one. And if I want to find how many possible outcomes there are in total for any license plate, again, I just multiply. 26 times 10 times 10 times 10 times 26 times 26 times 26 means that there are a grand total of 456,976,000 possible license plates. Following that specific format. Okay. One more slide here. I'm going to take us back to yesterday's lesson, where we figured out how many possible seating arrangements there are for 4 students sitting at a group of 4 that looks like this. And I told you guys that there are 24 possible outcomes. There's actually a really quick way to figure that out besides me listing every single one like I did here. All right, and it's using that fundamental counting principle. Think, how many possible students, if I have student 1, 2, 3, and 4, how many possible students are able to sit here in this first seat? There are 4 possible students that I could sit there, right? In that first event, there are 4 possible students I can put in that seat. Now, once I seat that student, how many students could I put here? How many students are available left? After I seat that first one here, how many are left for me to put here across from them? Well, that would be 3 students, right? After I put one here, there's only 3 left to put in this seat. And how about next to that student? After I seat these first 2 students, how many possible students are left to seat here? Well, there's only 2 students left, right? And once I get to this last student, there's only 1 more student left to put in that seat. And it turns out if I multiply these numbers, right, the first event is 4 possible students times 3 possible students for the next seat times 2 possible students for the next seat, and I got that 1 student left over who has to sit in the last open spot. It turns out that there are 24 possible seating arrangements.